this, is it use of?
No.
Not really, I guess it comes later, but yeah, it's arctangent, right? So you should have in mind the process. This is what you want to get to. What's the first thing I try and achieve? The 1. Okay, how do I make this into a 1? Okay.
Divide by 1/6.
Yeah, you could either multiply top and bottom by a 6 or divide out a 6. There are a lot of ways to make that happen, but that's the way I think of it. Are you cool with that? That then becomes 1 plus 4/6 or 2/3 x to the 4th down there. Do you agree with that?
Yes.
Okay. Uh-oh, I heard a Yoshi. All right, so what shall you, now in this idea then, it seems like u squared needs to be 2/3 x to the 4th, right? Which means u is the square root of 2/3 x squared, so du is 2 times 2/3 square rooted times x dx. So x dx is 1/2 square root of 3/2 or something along that line. Do you agree with that?
1/3, I think. I think it's 1/3.
Oh, did I make a
Because
mistake?
1/6 times 2. This one.
Oh, when I bring it up.
Oh,
there.
you did
yeah.
not.
Sorry, I haven't. You're right.
Oh,
I
yeah.
haven't put it up there. So when you do that substitution, it's 1/6
divide.
times 1/2 times the root of 3/2, and the top becomes du, and the bottom becomes 1 plus u squared. Do you agree with all the coefficient mumbo jumbo output? Okay. Correct me if I'm wrong. It's entirely possible I made a mistake. Or you might have done this part differently. I don't know. Here you go. 2/√6. Can I keep it like this? Oh, 4/6. Oh, sure. Yes. Would you prefer I go back and keep it that way?
This way also.
Yeah. Should I? Did most people leave that as 4/6, not reduce it to 2/3?
No. Maybe, I
Okay.
guess.
So since, yes, I'll be happy to. Yes. Sure, no problem. I mean, it's important to check that you did it right, so that's fine with me. If that helps you check that you did this properly, I'm down. So 4/6 x to the 4th, and this is 4/6 x to the 4th. That's what you mean, right? Okay, so u is the 2/√3 x squared. Is that what you're looking at? And therefore du is √6. Sorry, I don't know why. Yeah, I'm sorry. I apologize. So 2/√6 x squared, correct. 4/√6 x dx. Do we agree with that? Therefore, √6/4 du equals x to the x. Do we agree with that? Okay, then. This substitution, I get 1/6 times √6/4 du over 1 plus u squared. Wait. All right, so that's √6/24, arctangent of u, and arctangent of u is arctangent of 2/√6 x squared. Something like that or equivalent. Are we cool?
Yes.
Okay, cool. Today's lesson, did I hit record on this? Yes. Okay, today's lesson is a good one. It's actually a pre-calc lesson, and so Miss Karen might have touched this, but it wasn't in the green book, so she would have had to touch on the side, which is entirely possible. She does that, which is awesome. So graphing rational functions by finding horizontal or slant asymptotes. Does that sound familiar? Slant asymptotes sound familiar? Sometimes called oblique asymptotes. Okay, would you write above this oblique? Slant is in some textbooks called oblique asymptotes. And so if somebody says, well, find the oblique asymptote, I'd like you to know what it means. It's a bit of a mixture, different from text to text. It's different. All right, so the idea is we want to graph a rational function. And let's start off with the stuff you should definitely know that if you factor it, that allows you to find what I would consider to be the inside stuff. Right? The inside stuff being the holes, the vertical asymptotes, and the x-intercepts. Under what circumstances do you have a hole? If?
We do.
Are you sure? Alrighty then. So let's scratch this and give me 30 seconds while I... Sorry, sometimes I teach it and I don't like what I did, so I go back and change it, but I forget to change my slides. So you have 70, 80... Sorry, lo siento, mijos. Okay, so
The hell is that?
I'm going to dump this and look at this. Actually, I need to do the copy. Okay, is this about what you have?
Yeah.
Okay, cool. Yeah, I like it. Don't condemn the man's enthusiasm. I don't know, I felt like a little negative. I'm with you. All right, sorry. So here we go. Apologize. So does this look like about what you have? Okay.
Yes.
All right, cool. All right, so here we go then. We're still going to factor it, and it's x times x minus 4. I imagine 9 caused a scale change, and I don't know why that would be a problem. But all right, so you have this, yeah? So back to the question then. How do you know if you have a hole when you see a rational function or not? What characteristic is that?
Numerator and denominator go to 0.
Yeah, you have a common 0 over 0. Now, would you, I think you'll agree that 0 over 0 is a problem. What would happen as you approach 0? Like at x equal 1, what happens to those? They divide out, right? As x equals a half, what happens to those? They divide out. So very much the idea of a hole happens because as you approach, these are constantly dividing out and they're not even really there. It's really like, what does the graph of that look like? And the only difference between that and this is there's a hole at that 0. Otherwise, those two are exactly the same because those are constantly dividing out at non-zero points. So that is to say then, you can find the y of the hole by just saying, what's the limit as x goes to a of the function with the hole removed? If I take the limit of this, as x goes to 0 in this case, what does the function approach as we get closer and closer to 0? Negative 4/5. That limit is the y value of the hole. I have no idea what this graph looks like yet, but at 0, negative 4/5, the graph approaches that point but doesn't exist at that point. You with me? All right. To the numerator, when the numerator equals 0, what does that mean for the graph? X-intercepts. And where the denominator equals 0, what is that? Vertical asymptote. So in this case, I have x-intercepts at, after you remove the hole, I have an x-intercept at 4 and a vertical asymptote at 5. Okay? After that, it becomes about end behavior. End behavior means what happens as x goes to infinity or negative infinity. In many cases, they're the same. In fact, in most cases, they're the same, but they don't have to be the same. What is the infinite limit to this? What's the limit as x goes to infinity of this guy, x minus 4 over 5 minus x? It approaches negative 1. All right. That said then, that negative 1 is a guide for the outside of the graph. That's not an interior horizontal asymptote. Don't think, oh, I can't cross over the middle of that. You can cross over the middle of that. That's for how it behaves at the edges, not the inside. Understood? Yeah. Okay, so that then being said, we can start to look at this. If it approaches the asymptote on the negative side, it must be below the curve, yeah? Above or below, I guess you could get into that. I don't really care that much, so just approach the asymptote. What's it going to do after it passes through the hole? in the region between 0 and 4. It's going to constantly increase until it hits the x-intercept. Now I could verify that by taking any negative number here. If I, for example, took any negative, whatever, negative 1, wouldn't the y be negative 1 minus 4 is negative over 5 minus negative 1 is positive? So doesn't it make sense that y is negative, and so that following that asymptote's logical? You with me?
Yes.
What happens then when we trip over 4? Well, the top starts to be positive. The bottom is still positive, and so positive over positive, positive, we're going to follow that vertical asymptote. And then when I go below, or above 5 rather, 6, top is positive, but the bottom is negative. So what will it do in order to follow those asymptotes and be negative? You have to do this kind of upside down L shape. You with me?
Yes.
All right then. I should have finished this end behavior. Sorry, these notes. If the limit as x goes to infinity is 0, what does that imply graphically for the end behavior? Remember, this is y then is going to 0. If y goes to 0 on the outsides, the graph approaches 0. And so there's a horizontal asymptote at the x-axis, or in other words, at y equals 0. What if the end behavior is that the function approaches a constant? What's going on graphically there? There's a horizontal asymptote at y equals c, right? Now then, the part that's a little trickier is if, as x goes to infinity, y goes to infinity, then that actually could be a lot of different cases. It could follow a slant asymptote. It could follow a parabolic asymptote. It could follow a cubic asymptote. There's actually a lot of different asymptotic behavior, but it's more than just horizontal is the key. So let's get into that. Let's do a very easy case. Y equals negative x squared plus 4. Let's go with factoring. How's that factor, please? All right, so negative out front and x plus 2, x minus 2. Another person might say 2 plus x, 2 minus x. It's not the same either way. You cool?
Yes.
All right, so tell me, does this have a hole?
No.
It does not. Does it have, how many x-intercepts does it have? 2 at?
2 and negative
2 and negative 2. And at what x is the vertical asymptote?
2.
At x equals 0. I remind you when you give vertical asymptote equations on a test or homework, give equations, x equals 0, not just 0. It's important. And last but not least, the end behavior. Now, the end behavior, as x goes to infinity, what does y go to? Negative infinity. And as x goes to negative infinity, what does x go to? Or what does y go to? Positive infinity. Now that is to say then that the graph should do that on the outside. Now then, finding the path. Okay, it does that, but what kind of path is it? You know, is it going flat, or is it steep? Is it curving, or is it linear? So what path? Well, to find what path, that's really saying divide to find the slant asymptote. Now, each problem is different. Different problems require different division skills. This, I don't need to actually show any long division. To divide that, I could actually just split each one over x and reduce. And so this is something like negative x plus 4 over x. Are you with me? Okay, now let's be clear here. Y equals negative x squared plus 4 over x is equal to negative x plus 4 over x. Those two things are exactly the same, but each one tells me different things. This one makes it easy to find vertical asymptotes and x-intercepts. I don't necessarily look at this and say, oh yeah, the zeros are 2 and negative 2. They're kind of hidden in here. Here, it makes it easy to find the x-intercepts. This, though, is the key for the end behavior. As x goes to infinity, this remainder goes to 0. And so our equation will start to get closer and closer to just straight up y equals negative x. That's the slant asymptotes, okay? If that remainder goes to 0, our graph approaches y equal negative x. Y equals negative x is obviously a y-intercept of 0 and a slope of negative 1. So that's what our graph will start to get closer and closer to as we go on. Now, I could definitely sign test over here, say at x equal negative 3, and look at the signs. Let's go back to factored form. It's always nice to look at factored form for signs. At negative 3, I'd have a negative, a positive, negative, a negative, and a negative. Altogether, 4 negatives. So, positive. Well, that's great because there's no way it's going to follow that asymptote unless it's positive, yeah? So it's going to follow that asymptote until it hits that x-intercept. Once it touches that negative 2, this factor, I reckon, is going to change now because that's what the 0 is. That's where that 0 came from, is that term. At negative 1, I'd be negative, positive, negative, negative. 3 negatives, then, is negative. So what's the graph going to do? Obviously, if y is negative, it's got to go below the axis. What does it do? It approaches the vertical axis. All right? After I pass over 0, I imagine that denominator is now going to switch signs. At negative 1, for example. Negative, positive. Sorry, negative 1. Negative, positive, negative, positive. Did I say negative 1? I think I meant positive. Negative, positive, negative, positive. That is 2 negatives, and therefore positive. So it's got to be above the axis, and therefore probably follow the asymptote until it hits the x-intercept. And then it's going to switch signs one more time, 1 negative, and it'll follow that slant asymptote while you're at. Are you tracking? How many relative extrema does it have?
4.
None. Okay. All right. Now then, let's look at gradually more complex case. Look at the next one. X squared plus 2 over x plus 1. Does it have any x-intercepts? Or at what points does it have x-intercepts?
At positive and negative root 2.
Positive, negative.
Square root 2.
Let's look at, do x-intercepts come from the top zeros or the bottom zeros? Top zeros. And the top has 2 imaginary zeros. And so that is to say it has no zeros. X squared is always positive, plus 2 is always 2 or more. There's no way for that to be negative or 0 unless you have imaginary numbers, which we don't deal with in calculus. Okay, so there are no real zeros in the numerator. Not everything has real zeros. What about a vertical asymptote?
X or y. X equals negative 1.
X equals negative 1 is a vertical asymptote. So in this case, I have no holes, no x-intercepts, and a vertical asymptote. Cool? Now the end behavior here is going to be a little more complicated because it's not a single x in the denominator making division super duper easy. It's a little more complicated because now I'm going to have to actually divide. Synthetic or long division. Which one do you want to do? Long division it is. Great. All right. So x plus 1 into x squared plus 0x's plus 2. Don't forget your placeholders. Start by saying how many times does x go into x squared? 1x time. Multiply x squared plus x. Change signs. Draw the line. Bring down the next factor. How many times does x plus 1 go into negative x plus 2? How many times does x go into negative x?
Negative 1 time.
Negative 1 time. Multiply negative x minus 1. Change signs. Draw the line. I get a 3. And that's my remainder. 3 over x plus 1. Okay, cool. Now then, That is to say that my end behavior is going to follow, so my end behavior. I know it's going to be going to infinity as y goes to infinity, x goes to infinity. As far as how it will go, my equation y equal x squared plus 2 over x plus 1 is equivalent to x minus 1 plus 3 over x plus 1. Again, those two are equivalent, they just different forms, right? The whole idea of end behavior is as x gets large, the remainder goes to, yeah, as x goes to infinity, the remainder goes to 0, which means our graph starts to approach. So y equals x minus 1. Y equals x minus 1 is the slant asymptote. Again, it's always the case that the remainder will go to 0 in this problem. So, if I graph x minus 1, that has a y-intercept of negative 1 and a slope of up 1 over 1. So I've got a slanted or oblique asymptote there. Now I could sign test, and it's a good fallback, but there's a way to think your way through the graph as well. First of all, common errors here. Some people say, yeah, I'll go for a graph here and a graph there. Tell me why that cannot be. It's not a function. When I put in 3 or negative 3 into that, how many y's do I get? The answer to that is 1. When I put negative 3 into that, I get exactly 1 y coming out, right? This is a function. For any one x, there is 1 y. This cannot be. I can't get two different curves in the same x region. Okay? So in terms of where or what region, first of all, know that vertically speaking, it's got to pass the vertical line test. It is a function, so it's either here or there, and either here or there, never both of these, and never both of those, right? Okay. Give me a reason why it's got to be down here. I can think of two. Give me one. If it's here, what does it have to do?
It has to go through 0.
It has to go through 0, and does it have a 0? No, that cannot be. Here's another reason. Think about that remainder. I know we're kind of blowing off the remainder, but the remainder has some use. All right? Our function is like x minus 1 and this guy. For x is less than 1, what's the sign of that remainder?
Negative.
It's negative, all right? So our curve is like x minus 1, but a little less. And so if our curve is like x minus 1, but a little less, it must ride below. And so I know that the curve has to be down there. Again, either by sign test or knowing there's no x-intercept, or by thinking about what is the sign of the remainder happening. You follow? Does that make sense?
Why can't you cross like slant asymptotes?
You can. You can. Okay. I know it can't cross up here because I don't have any x-intercept. That's why I know it's not going up here. You can cross a slant in here. It's not like interior horizontal asymptote. That's a really good question. Thank you. Okay. On the side right of 1, I know it feels like there's lots of regions. There's one region. It's above 1, period. Okay? It's not, is it here and here? It's one of the two. I know that above 1, that's positive and that's positive. So it's got to be above the x-axis. So I feel like it's got to be here. And again, the remainder will help you. Our curve is like the line plus the remainder. When x is more than negative 1, what's that remainder? Positive or negative? Positive. So it's like the line and a little more. So it's got to ride above this slant because it's a little more than this line. You with me? Kind of?
Yes.
Okay, good. I'll take it. How many relative extrema does that have?
2.
2. It does. It has a relative minimum. All right. Is this, what is this?
That is,
So there is deja vu going on. Didn't we already do these?
yeah, we just did this.
I don't know. Sometimes I just paste in slide templates. You don't like the rain cloud?
No, I love the rain cloud.
Oh.
It's so random.
Oh, no. Yeah, that's, I like random. All right,
Just random.
let's go to this one.
Oh, that is
Is this what you have?
Yeah, that's okay.
Okay, cool. All right, so what do you reckon I should do first? Factor, yes. x, that would leave me with x squared minus 4, which would further factor into
X plus or minus 2.
x plus 2 and x minus 2, which is the blank of squares pattern. Yes, difference of squares. Yeah. When I say blank, I mean it's not because I forgot it. Whatever. All right. How do you factor the denominator?
X minus, X plus 3, X minus
X plus 3 and x minus 1 in either order. So are there any holes?
no holes.
There are not holes. Where are the x-intercepts?
Negative 2,
Negative 2, 0, and
2.
2. Where are the vertical asymptotes?
1 and negative 3.
1 and negative 3. Do we all agree on the inside material facts?
Yes.
Okay, then let's talk end behavior. How do I, now I could take the limit, but I really just jump to dividing to get the end behavior. The minute I see that this is not a horizontal case, do we actually agree that this is definitely not a horizontal case?
Yes.
Okay, because there's more power in the numerator. Then I start to divide. X squared plus 2x minus 3. It's time for you to practice dividing skills. So would you divide that on your own? And then we'll confer. What are you getting for an expression? X minus 2 plus 3x minus 6 over x squared plus 2x minus 3?
Yeah.
All right. So what's the slant asymptote we're looking at here? Slant is just x minus 2. When you go to find the slant, imagine the remainder term going to 0, and then what's left will be the slant asymptote. So this will follow x minus 2. Y-intercept at negative 2, up 1 over 1, excuse me, up 1 over 1. So this kind of skeleton of a graph, okay? At this point, it's up to you if you sign test or whatnot, but I know over here, left of negative 3, that I have no x-intercepts, so it really can't be up here. It has to be in this triangular region, right? I could sign test, but I got to be honest with you. If I look at each of one of these factors and they're all first degree or odd degree, what'll have to happen every time you jump an important point? It'll have to switch signs, okay? If it's not squared, or there wouldn't be a sign change, then you're pretty well sure there's going to be a sign change. So if it was negative below, then when you pass over negative 3, this guy is going to switch signs, causing the whole thing to switch signs, and it's going to be positive. When you jump below negative 2, this guy will change signs, changing it to negative, till I hit 0, which has to be touched as an x-intercept. That'll change signs, causing my whole graph to go positive. When I go below negative 1, or 1 rather, that one will change signs, causing it to go negative. And this goes to Ms. Carver's very foresightful question, which is to say slant asymptotes can be crossed. I have to touch that x-intercept, and it's going to then follow this slant. Let's see if it's something like that. You follow? Okay, try one on your own, please. You're always free to change the scale, by the way, if you'd like to spread it out, you could definitely go by half, as long as you prove or show that you can. Right? Yes? Okay. What are you getting for your oblique asymptote equation or slant asymptote? What is it? Right, because that's good. Okay. All right. How we doing? How's your graph looking like that? Yes? Okay. We have about 9 minutes. Do you have a lot of homework questions? Okay, there is one thing I wanted to go over, but I forgot to put it in my notes. Let's just talk about this. You don't need to write it down necessarily. How would you approach that integration problem? Yeah, you'd have to divide that first. Okay, so you divide x plus 3 into 3x squared plus 6x minus 1. You'd have to do that first. I imagine you get something like 3x, some kind of linear thing with a remainder. And you'd integrate the quotient. Okay? That's, again, not in our book, but it's an important type of problem you should know. All right, that's it. Questions on set 30, 60, 79. 79. Questions on 79. If you have them, let's keep them up. Yeah, no question.
I have a question. You just with like the key for number 1, it said like the height ended up being plus 10, but like I feel like
The height is 1?
you do the height, you're trying to find it by like, like integrating the velocity and the acceleration. And like there's some conditions says 0, 8. And but like on the key on your website it says like the intercept would be 10, like starting
That's what it says in the back of the book too, but like use your high dimensional key.
Oh really?
Okay, so don't fall into the temptation that
Oh, because the cosine of 2 is
it's not this, yeah.
Cosine of 0 isn't negative 2.
Yeah. So please take your special physics people. When you integrate motion, please don't assume a constant is initial condition. It's not necessarily. Call it a constant. So I don't know, is that the issue?
It's, yeah, because like the two cosine of zeros end up like -2, not 0.
Yeah,
That makes
exactly.
sense.
Yeah, so that's why it's definitely. Okay, questions on 79? Okay.
So, yeah, well, so.
Ready anytime you are, just let me know, otherwise I'm gonna have to.
So 8 equals -2 cosine of 0 minus 6 times 0 plus c. That goes to 0. This goes to 8. Like you plug in 0 and you say 8 equals,
Oh,
and
that's
h of
right.
0. H of 0 equals 8. So you plug in 8 right there, and then you plug in 0 and row t.
You're supposed to skip the Easter living. Did you know you can do them without practice? So now you can do them. Wow, yeah, that'll be pretty
I actually only skipped 4 rows.
I'm sorry, I'm not gonna get to the one with the table at once.
So that's the extra credit for it.
Those are the ones you should skip. Wait a second, you guys skip the hardest ones?
No way.
That's smart about copy form. You should skip the easy ones, the tedious ones that you don't even do.
Hey Joe, you want to take it? Sure.
This isn't your set, these are your notes.
Oh. Michael, did you turn in my setting? Yeah. Oh, thanks. Good catch, Joe. Hi, Brady. Did you get your sets back? What? I got some late ones. I was not expecting that, but also not surprised.
Yes.
That's why I felt like
So once you go to your lesson, you really get
But it's not 5% less. So I actually studied for the test.
Alex,
goodness.
how did you do
Oh
on
my
last
goodness.
week's AP straight response?
I know I got it.
Like how long?
I'll try again. It's like that whole thing is like,
Okay, so I've done all three.
You what?
You're not good at satisfying. I turned my name and she's like, so we gotta get you to where you need to be. And I'm like, yo, thank you. Like, do you see my support? It's honestly so bad.
I have to get this one tomorrow, and I'm not looking forward to it.
Yeah, that one. No, you'll be fine. There's more time today. Yeah. On all three.
Wait, you guys here or waiting today? What time did you guys start? What time did you start? What are you playing? Singles, doubles, doubles four? All right. Clayton Sullivan.
Seemed like the volleyball team got a lot of games this year.
Yeah, I don't know how it worked out, but as a dad, I'm real happy.
I remember last year, I think it was like 4.
Practically none, yeah, I don't know, feels like it should be balanced every year, I don't know.
Yeah. I mean, football is kind of the same way. We got 6 out of our 9 games at home.
Really?
Yeah.
Dang, was it opposite last year?
Well, like, I think for most sports they do like every 2 years.
It does,
It's the same schedule, and so
Okay.
they just flip home and away
mm-hmm.
in opposite years, and so.
So it must have been opposite.
Yeah, last year it was the second year of the cycle,
Okay.
so we had
Oh, so,
we just played the opposite of I guess 2 years ago.
so next year you're gonna be a ton of away.
Yeah.
That's not your problem.
Yep.
Have a good day. Thanks. That's not your problem. But you don't care. No, I just. Hi. Uh-oh, I've been recording all this time.